Hello coders, in this video we will solve a first question in our uh, linked list. Like it is a part of LeetCode 75 and it is the first question. Let's see what the question is. And yeah, let me take you to the screen first. And here, this is the question, which is delete the middle node of a linked list. What the question says is you are given a head of a linked list, delete the middle node and return the head of the modified linked list. The middle node of a linked list of size n is n by second node from the start using zero-based indexing, where x basically this denote the largest integer less than or equal to x. Okay, so if we have even number, or first they have given the if n is odd, that is n is equals to 5, then middle node will be like for 1 we will have a middle node is 0, that is one node will be the zeroth node because counting start from 0 best. Two node means we have 0 and 1 and we will delete the one, that is the first node. Then when we have 3, then we'll delete that first node, that is 0 1 2, then we'll delete the first node only. For 4 we will delete the second node, and 5 we will delete the second node only. So basically let me visualize here first that we have one node, we will delete that node. We have two nodes, 1 2, then we what we will do, we have two nodes, so we have one nodes, so the linked list will be 0, like it starting from 0, so we will take the indexes, so we have 0th index, we will delete that. When we have linked list of length 2, then we have 0th index, then we have the first index, and we will delete the one, that is they told key we have a linked list of length 2, then we have to delete the first one, that is this one we have to delete. And then when we have a linked list of length 3, then we have to delete the first one only, that is 0 1 and 2, we have to delete this one only. When we have linked list of length 4, then we have to delete the second one only, that is 1 2 3, and we have to delete this one only, that they have told if we have a 4 length linked list, then we have to delete this two only. It means what you getting here, key whatever there a number, that is whatever there are nodes in that linked list, that is n, when you take n by 2, that number that number that indexed node we need to delete. That if we have 2 by 2, it is give 1, and we have to delete the first, that is one node. 3 by 2, it is also 1, we have to delete 1. 4 by 2, it is 2, we have to delete the second one, that is 2, that is 2 number, that is the second number node we have to delete. Then we have n is equals to 5, that is when we have n is equals to 5 nodes in a linked list, and we need to delete that. 5 by 2, that is 2, that is we have to delete again second. So it is clear that if we count a number of nodes are there in linked list and take a middle node, that is mid, let's say we count the number of nodes and we know how to count number of nodes. Let's take a current node is equals to head, and just take a while loop in current, while current is there till go like n start n is equals to 0 and current is equals to head. And while current, what we will do here, key we will current is equals to current next, and it was the first node, that is n plus plus, we will take 1, and likewise we will do, right? So what I am trying to say here, key like this we can calculate the number of nodes, and when we calculate the number of nodes, we will take middle is equals to n by 2, and then we will delete the mth node by taking two pointers, that is first one and next one, that is the previous one and current one. When the current one is at m, then we will just do key next previous one next is equals to current next, and we will leave that current node. So basically throughout this, what we understood, key we will count number of nodes, how many number of nodes are there that we can count by using this while loop. And for the middle node, we can take m is equals to n by 2, then we'll get the index of the middle node. and we can use two pointers, and we can do that in big of n time. Okay, so basically here we did it in big of n time. And yeah, and can we do it in less time, that is big of less than big of n time? The answer is yes. There is an algorithm that is uh, tortoise algorithm, we can say. Tortoise or rabbit algorithm, we can say कि the tortoise that is the slow one, rabbit which is the fast one, and the rabbit goes two step ahead when tortoise goes one step ahead. Likewise, one take will node take will take one node that is slow, will go one step ahead, and will take a fast node which go two step ahead, and then we'll delete the middle one. And for that, what we can do here, keep, let's take we have this linked list that is 1 2 3 4 and 5. We have this linked list, so I'll first start the slow, and my slow will be here and fast will be also here. In next step my slow will go one step ahead, that is this will be here, but my fast goes two step ahead, so fast will be here at 3. In next step slow will be here at 3, and fast will be here at 5. Now we will stop because fast next doesn't exist, that fast next is null. And now we have to delete the slow. But how we can delete the slow? Because we are at the node which we want to delete, and we have to be before that node which we want to delete, right? So how we can what we can do here? So one thing coming in our mind is just do it like this. Just fast take for fast next to one step ahead. Snake one step ahead means in one step we move slow by one step and fast by two node. So take, while initializing only we will initialize like this. Keep slow is at head and fast is at heads next. And in next step what we will do here, the slow will be at 2 and my fast will be at 5, right? So how here I am at the node which whose next node we have to delete. So slows next is equals to slows next. So slows next is this. But what we are improving is like what we are improving that link. Slows next is slows next. So we will just do slows next is 2, next will be 4, and the 3 will be remain as it is, like 3 is next, slows next is slows next, and the slows next will be deleted. Okay, so basically we are modifying the link, and we can get that. So it will, this is the case of odd length. Let's see case of even length. 1 next 2 and 1 next 2 next 3, 3 next 4. Okay, so in this case what I told you, keep take slow at head and take fast at 2 point ahead. Like 2 point ahead means what? The first step ahead basically. That is 2 pointer ahead. The slow fast will be the fast next. And what is the fast next here? 3. In next step we will go here at 2, and fast will be at next, that is it will be at null position. What the next is? There is a null, right? So here in this case also what we had to delete, that when there is a 4 we have to delete the second one. So 4 is basically what? This is the 1 is at zeroth index, 2 is at first index, and 3 is at second index, and 4 is the third index, and we have to delete the second one, that is the slows next, that is 3. Okay, so even and odd case both are getting solved here. Let's see the first, that is the minimum odd length, that is 1. If there is one length node, what we want key, we don't want that then. So if head is equals to null or heads next is equals to null, then we have to return null because we don't want that head, right? What if we have two, like that is two node lengths, two length list. 1's next is equals to 2. Okay, so in this case what we have to do here, if we have two length list, we have to delete the first one, that is this one. And what we are doing here, slow is at here we have a slow, and fast will be at fast next, that is it will be at null. So for while loop, what condition we can add here, ki if fast is exist and fast next is exist, or yeah, fast next exist, or the fast next is exist, we can say ki here fast, either fast should exist. Here in this case we understood this ki fast is, if fast isn't exist, then we have to break that loop, because fast is here. Now the minimum even length can be 2, I mean it can be 0, but if it is a 0, that is head is equals to null, then we are returning null only. Then the existing length, that is 2, then fast will be at null. Then we have to delete the second, that is the first one here, 0, and first integer, that is 2, and slow is at 1, so we can delete it. So that condition which is starting the starting with the first step, that is getting clear here. Let's take three length node, that is 1, 2, and 3. Here also my yes will be here, and my fast, that is fast will be here. And what I'm saying ki if my fast exists, and if my now I have to delete the second one, so I have to add the condition, that is if my fast is, either my fast should exist and my fast next should exist, then I will go to the next step, where in next step I'll update my slow pointer to the slows next, and fast pointer to the fast next. Okay, so two conditions clear here ki in while loop we will have two condition. First, the fast should exist and fast next should exist, then we can update our slow and next. And the more important step is the slow should be at head and fast should be at heads next. At that position we will start the step. Okay, and yeah, it is what it is, like it is the optimal approach that I could tell, which can complete in big of n. The first one also getting completed in big of n, where we are calculating number of nodes, how many number of nodes are there in linked list first. Then we are taking a variable where we are storing the middle nodes index, that is n by 2, and we are traveling it to that node, and we are just updating the link, that we are just updating the list. But here what happens, first we travel for the to take the number of nodes, then we travel to delete to delete the middle node in that list, so we travel two times. But at here by taking slow and fast, we just traveled one time and we deleted that node also. So this one is the optimal one, and we can solve it using that, and let's see what how we can code it. So yeah, let's take a list node of, like before that we will check if head exists, if head isn't exist, and if heads next isn't exist, then just return null. Cause if there is nothing, if there is just one node, then we will delete that node, and there is nothing, then there is nothing to delete, and we will return null. So list node is slow, and we have list node second, that is the fast one. Okay, and my slow will be at head, and my fast will be, here we complete key, if there is a 0 node, there is a 1 node, that is heads next is null, means what, there was only one node. If we have two node, then fast will be the, like if you have two node, then initially the fast value will be null only, because heads next will be the next node, and that's next will be what, null, right? So we have to check first if my fast exists and also my fast next is also exist, then we will go here. the slows next is slow is equals to slows next, and my fast is equals to my fast next. Okay, and till then my fast, when my fast will be at last point or my fast will be at null point, this will break, right? We have to take the middle node to delete that node. So let's take we'll take the middle node, that is the middle node is equals to my slow's next node. I'm not saying that my slow will be at the middle, my slow will be at the uh, the node, one node before that middle, cause we are starting from first step only, that is we'll take a slow at head and fast will be at slow that heads next. We are not starting like slow at head and fast at head. At that time my slow will be at middle and my fast will be at last or the at null. But as we are starting with the first step only, that keeping our fast at one step ahead, that is one step ahead means what, the heads next, that is 2 point ahead. From that point we are starting, so that's why our slow will be 1 point before of the middle. So slows next will be the middle node, and we have to delete that. Slow, our slows next will be the slows next, and we have to delete the middle node. So delete the middle node and return the head. Okay, and let's run it. No network error. Okay, what happened there? Okay, I think it's good now, and let's run it again, and then submit it. Total time complexity is big of n. What it's saying? Okay, if there is only one node, then it's not getting it. How? We did it right. If our head equals to null, or my heads next equals to null. Okay. I got it. Keep it as that is. Just return here null. Okay, and run it and submit it. We did that. That was my bad. Okay. Okay. So time complexity here, it beats 100% code in time complexity. If we analyze the time complexity is big of n, and for the space complexity also here it will take a big of 1 only, cause we didn't store it, we are not storing it anywhere, so it will be constant, that is big of 1. Yeah, so yeah, this was for today, like this was all for the today, and we'll meet in next video. Till then, bye bye.